Okay.
She's like, how old are you?
Okay, before we carry on with this unit, I have to remind you of a definition of something. Somewhere over here in this blank space, don't write it down if you don't know the answer. As a matter of fact, don't write anything down until we discuss it. Somebody define the word variable for me. Do not tell me what one looks like. Do not tell me what a variable in math class is. Define that word for me. What does it mean to say something is variable? Omar? No. That is a math definition. You're absolutely correct. It is an unknown number in math, but I don't want that definition right now. I want you guys to tell me what the word variable means. I will use it in a sentence if that helps you. The weather in Vancouver around springtime is often variable. Tasha.
Many possible outcomes.
Yeah, that's getting warm. Now we're on the right track. What? It varies. Well, that's using the word variable to define the word variable. Zach, is that allowed?
Yeah.
What does circumlocution mean? Well, it's when you're circumlocuitous. Okay. Yes, you're absolutely right. It does. But what does varies mean?
Like it's
Multiple
different. Like it's different.
It's amazing how many Zachs there are in the room. Hey, buddy?
I don't know. It's different.
You're absolutely right. It changes. Excellent. Okay, Sean, is that what you were going to say?
Yes.
Okay. Variable simply means something that changes. Now, in math, Omar has reminded us that it's an unknown number. Well, how can we reconcile these two things? If variable means something that changes, but it also means an unknown number, are they separate from each other? No, they are not indeed, are they? Because if I start with something, right now, you don't know what x is. Well, you do, because we've just done the unit, right? We all know what it is. But let's pretend that we are in grade 3 in Mrs. Back-Rumble's class, and we don't know what that is. So, unknown number, does it fit the math definition? Yeah, because we don't know what x is. Is it going to change? Yeah, because right now it's an x, but when we're done all our work, what's it going to be? 9, isn't it? So variables, Cassidy? Yes. Variables in math satisfy both the English definition and the math definition. Is everybody cool?
Yes.
All right. So, let's go on. We're going to write an equation to represent a written pattern. Now, remember I said we often use math to represent real life. Well, this is where it starts. Obviously, this is not a real life situation. Very rarely is your life going to depend on you putting toothpicks into triangle shapes. Okay? I'm going to guess that it's never going to happen. But the ability to see patterns and to predict patterns is something that is very useful in life. True, if you're an artist, possibly your life will very much depend on how you put lines together. You're absolutely right, Hayden. All right, so the first thing we're going to do is figure this out. I need to write an equation. As soon as I see the word equation, what do I need? I need an equal sign. I need something equals something, don't I? Excellent. And I need to relate the number of sticks to the figure number. Uh-oh. You guys are smart kids. 1, 2. What does that mean? There's 2 numbers. Do you know either of them?
Well,
You can find it out from here, but do you know them before we do any work? So I have 2 unknown numbers, don't I? So because I have 2 unknown numbers, I must have two variables, yes? So now we have to choose those variables. So the first thing we have to do to write an equation is we need something equals something, don't we? And something in math, when we don't know what it is a variable, yeah? So what would two good variables be for this? Hint, hint, there's a little chart on the right that has some letters. Oh, look at that, brilliant! F is one variable, and what variable is that? What does that represent? The figure number. This is what is meant by defining a variable. Am I writing? So you should be. That's what we mean by defining a variable. You give it a name, f, and then you tell what it is. What is the other variable? N, which in this case, says right here, is the number. I'm so lazy, I'm doing the number sign. I'm so sorry, guys. I just am. Number of sticks. Now, can we now possibly think of it or start working on an equation? Yes, because we have our two numbers, don't we? Okay? But before we go any further, we got to do some more words. Okay? We got to do some more terminology. I'm going to teach you two new words today. All right? Variables are independent or dependent. Please highlight both of those words because I'm going to use them all unit. You need to be very comfortable with them. Okay? We're going to start with the independent variable. The independent variable, and I'm lazy, I'm going to write indvar or IV. Now before we do any writing, I'm going to let everybody write a little more, but I'm going to need you to think in a moment. So get what's written there down so your brain can concentrate on what I'm about to discuss with you. Okay. Some of you have heard this from me already. Some of you may have heard this in science, because it applies in science as well. So you may have heard this already. If you have, I apologize. What does the word independent mean in English? What was yours, James?
Separated.
Separated. Maddie?
As itself, one.
You could do stuff by yourself. Yeah, by yourself as one. Is everybody cool with that? Are any of you independent right now? No, none of you. Why? You live with your folks or somebody. Somebody provides you a house. Somebody provides you clothes. Somebody provides you food. Right? You're not yet independent. You're on your way. Don't get me wrong. I'm not saying you're babies in the woods, but you're not independent yet, are you? Am I independent?
Yes.
Yes. I must take care of all my own business. Right? Everybody cool? All right. So the independent variable is kind of like that. All right? It's the variable that stands alone. The way I like to remember it, it's the one that's the same for everybody. Now that might not make much sense, but we're going to talk about it in a minute. Okay? Now you guys are smart kids. If the independent variable stands alone and is the same for everybody, then what is the dependent variable? Exactly right. The dependent variable changes when the IV changes. So if the independent variable, which stands all by itself, can do whatever it wants, if it changes, the dependent variable changes. Okay? Now I'm going to give you a social example of this, not a math example. Okay? Who's the independent person in this room? Me or you guys?
You.
Me. Let's say I am not as in control of myself as one should be, and I have a really crappy morning. I have a crappy morning at home. My morning classes are filled with punks and pains in the rear. Lunch was bad in the cafeteria and I forgot to bring my own, so I'm hungry. I don't have my water glass, so I'm thirsty. And I do not put all that aside and I bring it into the classroom. Does that then affect you guys? Yes. Understand? Okay, that's a social example. Now I'm going to give you a math example. Okay? All of us go to 7-Eleven.
They all ask us if you got the bag, so you all think we're stealing.
We all go to 7-Eleven together right now. Everybody cool?
I'm so down.
Are we all in 7-Eleven? So is that an independent variable or a dependent variable? Independent variable because we're all there. Only the girls buy stuff. Everybody with me? Okay. They go to the cashier and pay. Whose wallet has changed? The girls. So, the independent variable is the fact that we all went to SEV. The dependent variable is the money that goes out of your wallet. Who does it apply to? Only the girls. Got it? I'll give you another example. You go to work with your buddy. Your buddy works at McDonald's. His shift starts at 5 o'clock. You both walk in the door at 4 o'clock. Everybody with me? Okay.
Why is he bringing his bike to work at McDonald's?
Because you were walking by and because you do stuff like that. Everybody cool? We walk in the door at 4 o'clock. The hour from 4 to 5 o'clock, does that pass for both of you? Excellent. At 5 o'clock, what starts happening for your buddy? He goes to work. You've got nothing else to do, so you hang out at his McDonald's because you're lame. That's okay. But at 5 o'clock, what changes? No, the independent variable isn't the one that changes. What is another thing that starts changing? The guy starts working. What does that mean for him? He gets money. What do you get? Nothing. Is time still passing for you? So is it the same for both of you? Is your buddy getting money? Yeah. So which is the independent variable? Time or money? You guys are just saying both words. Read the definitions and think about it.
I said, finally, what's the plan? This is really confusing. It's the money.
Okay, no.
There's two things that are being counted. Okay? Okay? In the McDonald's. When you go to work, you are passing time and you are being paid money. Right? So those are the two variables. Right? Because those are the two things that are changing. One of them has to be independent.
I know plan.
Which is it?
The money has to be independent. No,
Isn't that
it's the time.
It is the time. Why? Emily.
It's the same for everyone.
Okay, here, I'll say it.
I would like Emily to say it since she was the only one that actually put her hand up.
Okay.
Because, like, for the independent variable, it's the same for everyone.
Yeah. Yeah. Absolutely right. Everybody got it? That's the way I like to think about it. If something is the same for everyone, but something changes for some people, then that makes the changeable one the dependent variable. I'll give you another example. Right here in this room, you guys have been here for 45 minutes, yes?
Yeah.
Have I been here for 45 minutes?
No. Yes.
Yeah, since lunch. I was not in this room at lunch, as Tasha will tell you.
Yeah.
Right? Everybody agree? Now, in that 45 minutes,
You are getting paid.
I've gotten paid. You haven't. Understand? Your time has still passed, but your money has not gone up. Your wallet has not gotten thicker, has it?
If I pass this class, then it will.
All right, so is everyone cool with that?
You get paid.
Everyone is cool? Guys?
$30 an age.
Okay, so now,
15 a C.
does everyone agree my chart here is cool, yeah? The first figure, F1, there were 3 sticks to make it, yeah? Second figure, 5. Third figure, 7. Fourth, 9. 5. Fifth, 11, yeah? What's the sixth going to be? 13. Okay, cool. We see the pattern. Now, let's pretend this is not an instruction class. Okay? And let's pretend this chart isn't made for us. I have this chart. Okay? Why is this get to be filled in?
Because that's how many times.
Is that the independent or the dependent variable? Because the first figure, no matter what I draw, is the first figure, isn't it? If I ask you guys to draw me a shape on your piece of paper, right now, don't do it, but if I say draw a shape, and I draw a shape, it's everybody's first shape, isn't it? Right? It's the first shape you've drawn. But they're going to be different, aren't they? So that's why this is the independent variable. Is everybody cool? Okay. Because it's the same for everyone. Right? Pretend if you took a piece of paper and covered up the triangles. Okay? Let's pretend I've done this. You don't know what that shape is, but you know it's the first shape. So that makes it the independent variable. Okay? Because it's the same for everybody. Now, we come to here, and we're going to make the equation. This is what is actually happening, isn't it? Okay? Here is where we're going to make the equation. So what is the first number of sticks? 3. Right? In the second figure, do I have that original 3 sticks? Yes, I do. And then how many are added? 2 more, which equals 5. Are we cool? In the third figure, do I have that original 3 sticks? And then I added 2, and then I added 2 more to get?
7.
Are we still cool? Okay, fill in the rest of this the same way. What's this one going to be? 2 plus 2 plus 2 to equal 9. And what's this one going to be?
11.
Now you guys are smart kids. Would a math guy ever write that? No. What would he write? What's the shortcut to 2 plus 2 times 4? Correct? Okay, everybody cool with that?
Oh, 3 times 6.
Everybody's cool?
You can't say times.
Can't put X. Okay. I think I know what you mean, but we'll come back to it. Okay, now, all right, are we good?
Yes.
Okay, now, which of these is dependent? The number of sticks. So here is my dependent variable, right? So it's the changes to this that are going to give me my dependent variable, isn't it? So what is happening here? What am I doing each time? I'm adding 2, correct? Now, you guys are smart. Math guys don't do plus 2, plus 2, plus 2, plus 2, plus 2, do they? They do times 2, correct? Okay. Be smart about this. the independent variable is the thing that has to change, yes?
Yeah.
To give me the results. So if something is multiplying by 2, is it this side or this side? Which is my answer? The dependent variable or my independent variable? The dependent variable is my answer. So I got to do math to the independent variable in order to get the dependent variable, don't I? So if I'm doing plus 2, plus 2, plus 2, that's the same as times 2, times 2, times 2, isn't it? So I must be doing the independent variable times 2, correct? Now, we don't have to call it the independent variable, do we? What are we calling it?
The IV.
F. So I don't have 2IV, I have 2F, correct? Right? And that is going to result in my number of sticks, yeah? Well, let's check. What's F here?
1,
1. What's 2 times 1?
2.
2. But I don't need 2, I need it to be 3, don't I?
Yeah.
So what do I need to do further to my independent variable to get the 3?
Plus 1.
Plus 1. Is everybody cool? Let's check if that works. What's my F here?
2.
2. So what's my F here? 2. What's 2 times 2? 4 plus 1? Did I need 5?
Yeah.
So have I done it right?
Yes.
Does everybody see how it works? Now I'm going to summarize it for you right here. Your IV plus some math has to equal your DV. Okay? And we did that, didn't we? We started with our IV of F, then we did some math to it, we multiplied it by 2 and added 1, and that got us our DV. Everybody okay? Now, we have done A, but now we got to do B. What is the number of sticks in the 10th figure? 1, 2, 3, 4, 5, 6. So what number do I need for F now?
6.
I want the 10th figure. So F equals 10. So what do I do with this? 2 times what? 10, because F equals 10, plus 1 will equal N. So what's N?
21.
21.
Ta-da!
And that, ladies and gentlemen, is some very powerful math because it allows you to predict the future.
Am I Harry Potter?
Okay? No, you guys you're laughing, but it does. I'll give you an example of it. Let's say you start saving money right now. You start saving $10 a week in your bank account. Using this math, you can find out how much money you'll have by the end of the year, by the end of grade 12, by the end of university or college, by the time you're 60. Right? You guys see all those ads on TV for preparing for your retirement? You know what math they're doing? That. You know how much money people pay to other people to do this math? Can you multiply? Can you add? Is there a reason you should be giving away your money to somebody else to multiply and add for you? No, but people give away millions to these clowns. I don't know, James, you tell me. It's adding and subtracting and multiplying and dividing.
I'm probably going to do one of those.
Is it hard? Are there fancy words in it that people think makes it hard? Right? If you're coming to me, well, I gotta get some money, I gotta do some saving, I gotta save for retirement, and I say, well, Omar, your independent variable's return of investment's going to be about 10%. And if it's going to be 10%, inflation is at 8%, then you've got to make sure that you've had 2% saved up over the course of the next 25 years, assuming, of course, you're going to live 25 years. But you might not, so we better make the dependent variable in this situation, X, because that's how many years you may or may not save, and you're all of a sudden, fancy words doesn't mean a darn thing, does it? Because all math is add, subtract, multiply, and divide.
You do your accounting stuff?
God, no. Never. Too much time.
Wait, you don't do your accounting?
No. I pay somebody to do my taxes. I don't have the time. But, as you guys are all aware, there is a saying, and your parents have said it to you many times, do as I say, not as I do. I am telling you right now, actually learn this stuff, because then you can save yourself buttloads of money and not give it away to people. Okay? All right, let's see if you guys can figure it out.
Either way, you're giving your money away.
Which of those is independent? What must you do in order to get a hit?
That swing 3 times.
You have to add one.
This doesn't make sense, does it?
No.
How can you swing once and get 5 hits? It makes no sense, does it? Mathematically, if it's one person.
Swings of what?
What if it's a whole team? What if I got a whole team lined up playing t-ball and we all take our first swing? 5 guys get a hit. Okay? The reason I chose this example is because at first glance, it doesn't make sense, does it? Because all of you said, well, if I swing the bat once, how can I hit something 5 times? You're thinking about that Bugs Bunny cartoon where they throw the slow ball, right? 1, 2, 3 strikes, you're out. But you hit it all 3 times. No. Understand? Everybody with me? You've got to use your head. Which of these has to be independent? It has to be the swing because you can't get any hits without a swing. Everybody cool? All right. So here's my IV, here's my DV, yeah?
Yeah.
All right. So what is happening each time? I'm adding 4. Right? And over here I'm adding 1. Now since I'm adding 1, I don't have to do any thinking here, do I? Because it's the next one. All right? Now you guys are smart kids. You remember in your heads that IV and math must equal my DV, correct? So, we know our swings is where the math is going to happen. Well, what math is happening? Adding 4, adding 4, adding 4, adding 4. We're lazy. Do we write plus 4, plus 4, plus 4, plus 4? What do we write? Times 4. So 4 is multiplying by our number of swings, isn't it?
Yeah.
So 4s is some math, isn't it? So we might have the answer, mightn't we? So let's check. Does 4s equal h? Well, s is 1. What's 4 times 1? 4. I need it to be 5. So I have to do a little bit more math. 4s plus 1. Everybody see it?
Yep.
Okay. Now let's put it into words. The number of hits is what? 4 times the number of swings plus 1. Not hard, is it? So now we write an equation, which we already wrote because we're so darn smart. And then I want to find out how many hits I get when I got 10 guys on the team swinging. So what do? 4s plus 1. But what's s now? S is 10. So what goes in for that s? 10. 4 times 10 plus 1 is 41. Does everyone see how it works?
Yeah.
It's pretty easy, right?
Yeah.
When you think about it, it's not that hard. So, let's go to the next example. Tegan goes to a carnival, costs for rides are right there. Write an equation that relates the total cost to the number of rides. So I've been given my two variables, haven't I? Everyone agree? Okay. One of those has to be dependent, and one of those has to be independent. Which is it? I've got C and I've got R. One of those is independent, one is dependent. Number of rides, Karina says, is the independent variable. How many people agree? I'm not going to say if you're right or wrong, just how many people say, how many people think it should look like this? IV and DV. Who agrees with Karina? She's getting 95% in the class. Who agrees with Karina? And who thinks it should be?
I know the answer. It's one that makes sense.
Black or red?
Red. Can I say?
James?
Can it possibly be IV and IV?
No. How can you have two independent variables? Then they wouldn't affect each other. No. It's something, it's a good question. If you have two independent variables, then they aren't affecting each other. Okay? That's like saying it's raining outside, so I'm...
You gotta go play some basketball.
Well, no, because I wouldn't go outside because it's raining. That's not a very good one. But it's raining outside, so my grandmother is 20. My grandmother is 81.
Wait, what?
They're not at all related, are they? Okay, but it's raining outside, so my grandmother got an umbrella.
That makes more sense, but it's still
Okay.
raining outside.
All right. So which of these is right, red or black?
Red. Okay, I got
Okay. You are telling me the cost is the independent variable.
Yes. Well,
Why?
because it stays the same.
The cost stays the same? Doesn't it say right here that the cost is added $2 for every ride?
Where's the?
Doesn't it say that? So isn't cost going to change?
Doesn't it go up?
no, it's going up.
Cost goes up depending on what? How many rides I go on. So it has to be the black one.
Oh, I thought that was like the entrance fee. Like,
Is everybody cool with that?
I don't even.
Does everybody see why?
You gotta have this.
Okay, Tasha. You walk into a movie theater.
Yes.
You don't see a movie. You just walk in. Sean walks in and sees a movie. Who pays more? Why? He saw a movie. So the amount of money Sean paid depended on whether or not he saw a movie. So that makes the movie independent because Sean's cost depended on him seeing the movie. So the ride has to be independent because if you go on a ride, you're not paying. If you don't want to ride, you're not paying as much as Liam, who goes on 30 rides. Understand? Okay? Now, let's make the equation. So to make an equation, I need a chart, yeah? Yeah, this fair is a ripoff. That's what all fairs used to be like before they started doing the all-day ride band.
Oh my god, $5.
Now,
And we paid for like the money.
what goes on this side? Independent or dependent?
Independent.
Independent, which in this case is what? Rides are. What goes on this side? Dependent, which in this case is cost. Everybody cool? Everybody agree? What is the fewest amount of rides I can go on? Really?
Zero.
You guys have parents? Do they go on the rides with you? Horse crap. They don't go on spin out. No, they don't. So the fewest amount of rides you can go on is 0, yeah? Is it going to cost you to go to the fair? How much? $5. What if you go on one ride? Do you pay $5? But you add 2, yeah? To get 7, correct? On the second ride, do you pay that first 5? But now you're adding $2 times how much? 2 rides to get how much? 5, 7, 9. 3 rides, 5 plus $2. Now how many rides did I go on? 3 to get 11. Everybody with me? Now you guys are smart kids. Please notice 5 plus 2 are, correct? So what if I go on an unknown number of rides? How much am I paying? $5 plus 2 times R will equal my what?
Unknown numbers.
My cost. There's my equation. Does everyone see how it works?
Because he's adding all the rides.
It's adding all the rides you might do. Now we know that Tegan did 4. So in this case, R equals 4, doesn't it?
Yeah.
Do I have an equation?
No.
I have an equation. Cost equals 5 plus 2R. Do I know R? It's 4. So my cost is 5 plus 2 times 4, which is
11.
13.
Sorry, sir.
Now let's say you're with a really badass dude who goes on 20 rides. How much is it going to cost him to go to this fair?
Yeah, right.
What's my R now?
20, so
20. And what's cost is C equals 5 plus 2R. 2 times 20 is $45. Does everyone see how it works? What's the only thing you got to remember? Independent variable and math gets me my dependent variable. Everyone cool?
Lesson learned. Go to sleep.
All right. Whoa, sorry, Tasha. Sorry. Speaking of cartoons, that was a very cartoon sound.
Lesson learned. Don't go to anything.
Mischief managed. Okay. Okay, guys. Let's see if you can do this, because I'm a little bit concerned. Marcel takes his summer job. Marcel gets paid $50 plus $2 for every box he packs. So what are the 2 things that are changing? The pay, because Marcel gets pay, that's being counted. And what's the other thing that counts? The boxes. Which one of those is dependent? Dependent. Pay. Why, Ashley? Because pay depends on how many boxes he fills. If he fills more boxes, he will be paid more. If he's a lazy sack, he will be paid less. So pay is dependent, boxes are independent. And then I say to myself, it's independent math to get to my dependent, correct? So let's make our chart. What goes on this side? Independent, which in this case is boxes. B for boxes.
Yep.
What goes on this side? P for pay.
Yeah.
If this guy comes to work and spends the entire day on Snapchat, how much is he going to get paid?
Zero. I mean, $50.
He's gonna get $50 because he's paid $50 a day. The boss doesn't know he's a lazy sack of crap, and he just hired him because he looked good and he interviewed well. Okay? Know how I know this will work? I used to deliver flyers, and sometimes I was tired, and I just throw them in a dumpster.
And then throw on the papers in the bush. And then go.
No.
Yes.
Never mess up on paper. The old people always complain.
I know. Now, let's say Marcel is a beginner and he is only able to pack one box. How much is he paid? $50 plus
40. I mean, $2.
two, because he packed one box.
That would say just 60.
2 boxes. 50 plus 2 times 2, correct? Because it's $2 for each box. 3. 50 plus 2 times how much? 3. Now you guys should already see the pattern. What if he gets super good and packs B boxes? How much does he get paid? 50 plus 2B. There's our equation. 50 plus 2B. Now, Marcel has gotten pretty decent. He packed 20 boxes today. How much does he get paid? Well, I write out the equation, not 50B, dummy, plus 2B. He packed 20 boxes. 50 plus 2 times 20, which is 50 plus... I'll wait while my grade 9s do 2 times 20. And then I'll wait while they add 50 and 40.
90.
Hey, wait, how long is he working?
Depends. That's why this type of job is good for some people, right? If you pack the boxes quickly and you can live a darn good life on $90 a day, you could be done by lunch and have the rest of your day free.
That'd be good to like do like.
My brother used to work at a place that paid you that way. He was a roofer.
My dad did that.
And he would get paid for how much square footage he could do in a day. He was very fast. So some days my brother would stop working at 1. I'm done. I've earned enough today. I'm going home. Yep. Now there's problems with that as well, right? What if you're slow? But then you might be not making very much per hour. You might be better to go work at Subway and get minimum wage per hour. You understand what I'm saying? But if you get good at something, maybe you want to keep doing that. No, one person can. One single person can live on minimum wage with a roommate if they are working 30 to 40 hours a week. Yes, they're going to raise the minimum wage, which is an argument that I do not want to have here. So like $10.75 or something. Yeah, it's an argument I don't want to have here because it's a problem. Because it means that unskilled labor is getting a raise just for being able to breathe. Whereas, say I'm the manager at a McDonald's. Do I get a raise because every minimum wager gets a raise? No. Probably not. Shouldn't I get a raise?
You're higher up.
I'm higher up. There's a reason I'm higher up. Understand? And that's an argument that people have against raising the minimum wage. Now my argument is simply this. We pay too much for work in North America. If I push a broom on BC ferries, I get paid $20 an hour. Right? Like, if I push that same broom at 7-Eleven, I get paid 10. What's the difference? Right? What is the difference in skill level for the job? None.
You're risking your life.
Way more people on the boat. It's still sad.
My friend, my sister-in-law worked at Safeway in the deli. She worked in the Safeway part where they make the sandwiches.
Oh, yeah.
So she had to basically run a Subway, right? You all have seen the sandwiches in Safeway. She was paid $22.75 an hour to make sandwiches at Safeway.
I know what my job is.
When I was the manager of Subway, I got paid $8.50 an hour.
What?
You were a manager at Subway.
So,
That's what.
the argument does not become how much minimum wage should be. The argument becomes, are we paying people too much to do jobs that shouldn't be paid that much? I'll give you another example.
Don't be trying to ruin it for that.
No, it's not ruining, because let's think about it. How much does a new car cost in Canada? The cheapest new car that you can think of. Do any of you actually know?
A Prius because they're half more
No.
like electric.
$10,000. You can buy the tiniest Mitsubishi car for $9,995. 10 grand.
Brand new?
Brand new.
Okay, what's wrong with it?
Nothing. It's brand new. It's 10 grand.
There's something wrong with the brand new cars with 10.
No, it's just a little car without a lot of features and things. So it's 10 grand. Is everybody happy with that?
Yeah.
That same little car
With a sunroof. is-
in India is 2,000. Why?
I'm going to India to get that car.
Why?
That's how.
Income is lower in India. So they don't have as much buying power. But there's also way more people.
They come here, get,
Right?
They go back.
Abney,
Live large.
have you been to India?
Pretty much.
People don't earn as much, do they?
Here, he's living in a mansion in India. I'll tell you that.
Yeah. But when you transfer the dollars to rupees, we're paid a lot more, right? And yet, you can still buy a new car in India, can't you? And people buy them, don't they? For about $2,000, or whatever that would be in rupees. That same car in North America is $10,000 for the exact same car. Why?
Can you afford it?
No, you can't. Why? Because our economy allows us to spend $10,000 on a car. There's no need for it. That is why there are people in the world that can live on $1 a day. Should they? No. That's horse crap. Nobody should be forced to live on that little money. But it's possible. Could we live on $1 a day in North America? $1 a day.
Yeah.
Yes. Yes, we can.
No. You are not living on $1 a day. If you were going to say that way, Sean, you're going to go dumpster diving. Somebody paid for that food. No, but you got to understand. That's what I'm saying, right?
You say because you trample like
Okay. Ladies and gentlemen, please listen. The bell is about to ring. Listen up.